So I'm going to show this to you now. I will put one question like this on your test as well, so you still need to do this. Okay, let's think back to good old days of elementary school. Remember how to do division? Remember how to divide 7 into 4, 7, 3, 1? I hope so. 7 goes into 4 how many times? 0. So 7 goes into 47 how many times? 6. Then you do what? 6 times 7 is 42. Good old long division, right? Then you subtract. Please write this down, okay? And then you bring down the 3. And of course you say to yourself, 7 times what gives you 53? And the answer is 7. 7 times 7 is 49. You'll subtract and you get 4. And then you bring down 1. 7 goes into 41, I think 5 times. 5 times 7 is 35. Then you got a leftover of 6. What do we call that leftover again? Yay, the remainder. I don't know if you remember this division statement, but 4731 is the same thing then as 7 times 675. And then I'm going to add to that the number 6. So this is the division statement. And yes, there are words that describe each one of these numbers. You've already correctly told me that the 6 is the remainder, so I'm going to write down the remainder here. Does anyone remember the rest of the terms to represent all these other parts? Quotient, yes, which is the answer. So I think that would be the 675. And then the last two are the ones that probably people forgot. Dividend, good, and so the dividend is the big number that you're starting with, right? Dividend, and you're dividing by 7, and they call that the divisor. Yeah. So these are just some terms. You don't really need to know the terms for my test, but I thought, you might want to know what they are. So an alternate form of the division statement is this thing down here, which they call P over D. And P stands for the dividend. D stands for the divisor. Of course, Q stands for the quotient. And R stands for the remainder. So sometimes people will write out the answer like this. They'll take the number 4,731, that's your P, and they'll divide that by D, which is 7. And that equals to Q, which is 675. And then there'll be R, which is 6 over 7. So this is an alternate form of the division statement. But the one up top in a row, I think, is one that's more common. So what I'd like to show you today, first of all, is how we can now use the same ideas to divide polynomials. Okay? So instead of doing numbers, we're going to now divide polynomials. And that's the first thing I want to show you today. Okay? Now the ideas are the same. So what I did was I picked two examples which were very similar. I hope you can see. 21 divided into 489. And instead of 21, I used 2x plus 1. And instead of 489, I used 4x squared plus 8x plus 9. So do you see how it's almost the same format? Okay. That will help us as I show you how to do these divisions. Let us go ahead and do the numbers first. So once again, let's go back to good old elementary school. I won't make you sit on the carpet, but we'll do this. 21 divided into 49. How do we do this? Well, 21 doesn't go into 4, so we'll take the 48. 21 goes into 48 how many times? 2, good. And then, of course, you would do 21 times 2, which would be 42. And we'll put that underneath. And then we'll subtract to give you 6. Then we'll bring down the 9. And you ask yourself, 21 goes into 69 how many times? 3, I heard. Thank you. And then you go 21 times 3, which is 63. And we'll subtract, and then you get 6. Okay? So the division statement for this one, of course, is just 489 equals to 21 times 23 plus 6. Okay? All right, ladies and gentlemen, we're going to do the exact same thing now with the polynomial. So listen up here. Okay? You see how in the numbers I said 21 goes into 48 how many times? Or when you estimate, you go, 2 goes into 4 how many times? And you say 2. It's the same idea here. So you should be asking yourself this question, okay? You take the 2x. So 2x times what number gives you approximately or close to 4x squared? So you should be asking yourself, 2x times what gives you 4x squared? So ask yourself, I'm going to put a little bubble. Get it? 2x, Deon says? Good. So that means, just like over here, how we found the number 2, I'm going to write 2x on top of that division bracket. 2x like this. Okay? So like what Dayon said, 2x times 2x gives you 4x squared. Good. What did I do after I found the 2 over here when I did the numbers? How did I get the 42? I took the divisor, 21, and multiplied by 2. So guess what I should do over here? I should take the divisor of 2x plus 1 and multiply that by 2x. And I'm going to stick that underneath. So let's do this together. What's 2x times 2x? 4x squared. Good. What's 2x times 1? That's 2x. So you see how I expanded this out and I stuck it underneath? Just like over here, I had 21 times 2, which was 42. Stuck it underneath. What's my next step when I did the division? Subtract. So I'd like you to do the same thing here, please. Go ahead and subtract. Okay, now put a bracket around here because I want you to understand we're doing subtraction of both terms. What's 4x squared minus 4x squared? 0. Good. How about 8x take away 2x? What would that be? What's 8x take away 2x? 6x. Good. Do you see how this is very similar once again to the left side when we did the numbers? Instead of 48 minus 42, we got 6. Now we're saying 4x squared plus 8x. Take away all of 4x squared plus 2x is 6x. What do you think I do next? How about you bring down the 9? Okay. And then you should be asking yourself the same thing now. 2x, that thing in front here, 2x times what gives you 6x? 3. Good. So I'll say plus 3. And then once again, I'm going to have to do the divisor of 2x plus 1 and multiply that by 3. And we'll do that together. 2x times 3 is 6x. 3 times 1 is 3. And then the same process happens. I will subtract. So 6x minus 6x is 0. 9 minus 3 is 6. There you have it, dear friends. You've actually done your first polynomial division. And if I asked you to write the division statement, I would ask you to write down the following. So I'll say 4x squared plus 8x plus 9, that's your dividend, equals to your divisor, which was 2x plus 1, times your quotient, which is 2x plus 3, plus 6. Okay, so there's your division statement. I'll give you a chance to copy that down first of all. And then I'd like you to try to write it in the alternate form as well. That's that fraction form. So the alternate form would have been the dividend, which is 4x squared plus 8x plus 9, divided by the divisor, which would be, I think, 2x plus 1. That gives you your quotient, which is 2x plus 3, and your remainder over your divisor, 2x plus 1. Okay. Now, I'm not too worried right now if you can write this division statement out, but I thought I'd do that just to try to solidify this concept. What I really want you to understand is how to do this long division. So I've got 2 more examples underneath that I'd like us to try together. Should I let you try example 2 on your own first? Maybe I won't, since Gavrili just came late, so I'll do it again for you. Okay. All right. So let's do example number 2, and I'll work on this with you. If you don't want to listen to me right now, try it on your own. But if you need some help, then listen. Okay? Here's what you ask yourself. X times what gives you 4x cubed? Help me, somebody. 4x squared. Notice I'm going to put the 4x squared on top of the x squared terms. I'm going to line them up. And then you should be taking your divisor of x minus 2 and multiplying that by the 4x squared, and then sticking it underneath. So that would be, I believe, 4x cubed minus 8x squared. Okay. Let's keep going. Let's keep subtracting now. So we'll subtract, and be careful when you subtract. The 4x cubed minus 4x cubed is nothing. But what's the negative 11 subtract negative 8? How many is that? Negative 3. Good. Bring down the 8x, and then you ask yourself now the question, X times what gives you negative 3x squared? Minus 3x. So, once again, take your x minus 2, multiply that by the negative 3x. We'll distribute negative 3x squared plus 6x. We'll also subtract once again. So notice when you subtract, always that term on the left becomes 0. That's the goal. And then 8x minus 6x is 2x. We'll bring down the plus 2. And ask yourself the same question now. X times what gives you 2x? 1. X times what gives you 2x? 2. Good. Take the x minus 2, multiply that by 2, distribute and stick it underneath. Finally solve, and what do you get as your remainder? 6. Good. Okay.
Every remainder has been 6.
Every remainder's been 6 just because. It doesn't always have to be 6. That's not my favorite number. Okay? All right, let's try the next one here, example number 3. I'll let you try this on your own, but I'll help you set this up first. Remember, this is division, so I'm going to rewrite it in long division format. That would be 2m minus 1. And I'm going to put here 8m cubed minus 1. Now, you might be thinking, Mr. Lee, why did you leave all that space there? Good point. Ladies and gentlemen, let me ask you this question. Okay, don't write this part down, but if I were to do this, okay, if I were to say 8,001 divided by 21, how do you write down the number 8,001? 8,001, is that like that? What do you put inside?
0, 0.
The 0, 0, right? So, and if you think about what's happening here, I've got an m cubed, but you may be thinking, well, Mr. Lee, where's my m squared? Where's my m? All those other terms in between. Well, they're not there. So what do I use to represent something that's not there?
X.
Not x, but I'll use 0. I'll say 0m squared plus 0m. Just like how we used place value holders for numbers, we can do the same thing for polynomials. So if you don't see a squared term or a linear term, just write down 0m squared, 0m. Okay? I would strongly suggest that, because if you don't, then when you do the division, you'll get lost with the terms, right? Because you want to keep them all in the same rows. This is just for our notation purposes. Okay, ladies and gentlemen, I'd like you to try this one on your own then. Okay, so think. 2m times what gives you 8m cubed? 4m squared. Okay, you finish this off, please, on your own. Okay? Give you a few seconds to do this. Then if you're done early, try the next question already. Okay? Okay, ladies and gentlemen, keep going, please. I'll give you my answer now for those of you who are still not too sure. 8m cubed minus 4m squared. Subtract. Okay, notice I've got 0, take away negative 4m squared. How many m squares do I have? Positive 4, thank you. Okay, and then you should be asking yourself the same thing now. 2m times what gives you 4m squared? What would that be? How about 2m? Okay, so you get 4m squared minus 2m. We'll subtract one more time. We'll get positive 2m. We'll bring this down. 2m minus 1. I guess that goes in once. That's just 2m minus 1. There you go. Remainder 0. Yay! Okay. All right. Ladies and gentlemen, turn the page. Okay. I've got one more I want you to try on your own as an exercise. So I'd like you to find the remainder, okay? So I don't really care about the quotient, but I want you to find the remainder of the next example here. So I'll let you try this right now on your own, once again. And let's see if you can do long division and get the answer. Okay? Go for it. Don't forget, if you're missing an x, put the 0x there to help you out. Let's think about what your answer is going to be here. Let's do this. I don't know, I'll do it with you. I'll do it faster though. Okay, be careful here. The first step here, some people will make the mistake because negative 2x minus negative x gives you minus x squared. Good. Not 3. Okay. Sorry, not x cubed. X squared. Minus x squared. Oh, oops. Right. My fault. Can I just erase that? Negative 2 minus positive is just negative 3x. Thank you. Just checking to see who's awake on a Monday morning. It's not me. Sorry for confusing you even more. Okay. Then I think the term is minus 3x. Minus 3x squared minus 3x. We're going to now subtract. That gives you positive 3x. Bring down the 4. This looks good. That would be 3. 3x plus 4. No, 3x plus 3. Got too excited. So the remainder is 1. Okay. Now, ladies and gentlemen, that seemed pretty painful, didn't it? To get the remainder. Too much work. Do you want to know a shortcut? Sure. Here's what I'd like you to do before we do the shortcut. Can you please rewrite this division statement out then? The dividend of x cubed minus 2x squared plus 4 is equal to the divisor of x plus 1 times the quotient, which is x squared minus 3x plus 3. And the remainder is 1. Good. Now, here's what I'd like you to do next. Okay? I'd like you to take this expression. I want you to evaluate f of negative 1. So I hope you remember this from grade 10. F of negative 1 just means plug in x equal to negative 1. And I want you to do this to both the left side and the right side of the statement. Okay? So if you could do it to the left side, please, the left-hand side. And I'll say here, you got negative 1, going to cube it, minus 2 times negative 1, you're going to square it, then add 4. Okay, get the answer for me. And then I want you to do the same thing with the right-hand side, please. This one's a little bit more complicated because you've got this divisor of x plus 1. So I'll say negative 1 plus 1 times negative 1 all squared minus 3 times negative 1 plus 3 plus 1. Okay? I want you to evaluate this, and then let's see what you get. Side and the right side. 1 and 1. What? So yeah, the left-hand side equals the right-hand side. But what else does this equal to? What's the 1? Yeah, which also equals to the remainder. Okay, ladies, it's okay. All right?
Yes.
Okay, so, ladies and gentlemen, the left-hand side equals the right-hand side, which also equals the remainder. So you might be thinking to yourself, well, Mr. Lee, how'd you get that? How'd you figure out that the number you should plug in is negative 1? Well, can you see something here? What happens on the right-hand side when I look at the divisor? What happens when I plug in negative 1 into my divisor right here? It's 0. What's 0 times the quotient? It's still 0. So what's left over? It's the remainder. So I'll tell you this, okay? There's something called the remainder theorem that I want to show you today. Okay? When you have a polynomial, okay, which I'll use this representation of the big polynomial as p of x, and if you're dividing by some sort of binomial which is of this form, x minus a certain number. So in this case, from above, I had x plus 1, okay? Well, the remainder is just equal to the value of the polynomial when x equals to k. Or what I'm saying to you is just plug in p of k. So really what you need to do, okay, is look at the divisor and say if it's x plus 1, you plug in negative 1. What happens if I change it around? What happens if I say something like this? The divisor is x minus 2. What do you plug in for k? 2. Good. So here's what I'd like you to do here. I'd like you to now use x equals to 2, and I want you to plug it into the equation to find the remainder. So this is the quick and easy way of finding the remainder of a big, long polynomial. Okay? So just go ahead, plug it in, please. Okay, so 2, something cubed, something squared, times 8, minus 12. Go ahead now and please calculate this one for me, and this is a special remainder.
It's 0.
Really?
No. How do you know what to plug in?
If it's x minus 2, you plug in the opposite, which is just 2. If it's x plus 1, you plug in negative 1. So it's always the opposite sign. See, it has
But
x
it
minus
says
k.
plug in. Oh, it's because it's written f of negative 1.
Yeah.
But it was just with x minus 2.
Yeah, x minus.
Oh my gosh, so difficult.
Okay, ladies and gentlemen, what do we get here for this remainder? 0. Excellent. By the way, when the remainder is 0, we have a special term for this, binomial. It's called a factor. Right. And so the next thing I want to show you, which is just an extension of the remainder theorem, is the following. If you had a binomial x minus k, and then I asked you to find the remainder, and you found that the remainder is 0, well, that just means that the factor is, or that just means that x minus k is really a factor of the polynomial. So once again, to find factors, you have to plug in the opposite of what you see, and if the actual result of what you plug in is 0, then it's a factor. So what I'd like you to do now is turn to page 3, and I've got 5 different binomials that I'd like you to try to find and determine if they are factors. Okay? So let me do this with you, and then after that I'll give you a quick break before we do the next part. But what number should I plug in for 5a? 1. Sure, so I'll plug in 1. Plug in 1, and I'm going to ask you to please calculate what that is going to result. And I'll bring out my graphing calculator now if you want to use yours too. I think this would be a good time. 1 cubed minus 6 times 1 plus 11 minus 6 equals to 0. So is this a factor, yes or no?
Yes.
Yes. Okay, for part B, what do I plug in? 2. Okay. 2 cubed minus 6. And how many of you are right now thinking, Mr. Lee, are you serious? You're going to make us plug in all 5 of these? You're so mean. Exactly. Okay. Would you like me to show you a nicer way of evaluating these things? We have to do things over and over and over again.
I can understand this way.
Okay. You have your graphing calculator? Bring it out. Okay, if you were to plug in x, just type in x to your calculation screen right now. Not the actual graphing screen, but the calculation screen. Just type x. Then press enter. You should get something.
Oh.
You might be different.
1,000.
10, 5, 12, whatever. I get on mine 10. Whoa.
Look at 1,000.
Okay. Now do this. X plus 5. Okay, so for mine, what do you think the answer is going to be? 15. On yours, is it always just 5 more than what you got? Right. Now, I can ask you to calculate x squared. So it does this, and for my answer, what should x squared be? 100. Hey, your calculator can actually calculate things for you. Now, what's happened here is that your calculator has stored in its memory that, in my case, x equals to 10. So what happens if you want to store a different number in your calculator's memory? Let's say the number 2, because you're doing example 5b. So here's how you store it in memory. You take the number 2, and there's this button on top of the on button called STO with an arrow. That's store. So I'm saying to the calculator, take the number 2, store it in, and I'm going to say X, so go ahead and use your X value above the apps button. And then now it says, okay, the X value is now 2. So now if I were to do something like this, if I say X plus 100, what would the answer be? 102. Yes. So now, why is this helpful to us? Because what am I trying to plug 2 into? I'm trying to plug into this big long polynomial. So my suggestion to you now is, why don't we just type in the polynomial? X hat 3 for x cubed. Okay, that hat button is on top of the division key. Minus 6x squared plus 11x minus 6. And if you typed it in properly and you press enter, it will evaluate this expression at x equals to 2, and your answer is 0. So therefore, this is also a factor. Now, if we want to evaluate the next one, what should the next one be? What value should I plug in? So I'll plug in 3. So instead of now going ahead and calculating this again, what can I do on my graphing calculator? Make x3 by doing this. Press the number 3, press store, press x, press enter. Good. And now what should you do next? Type in that function again. Oh no, I don't want to do that again. So let's show you another faster way of recalling something you just typed in before. Watch first, and I'll let you try. Do you see this? Oh yeah, some of your calculators have the scroll button. Mine's an old version, so it doesn't. So what I have to do is, on top of the enter key, do you see this word called entry? Mm-hmm. That's in yellow. So if I were to do second function enter, what it does is it gives me back the previous entry. I don't want that one. I want the one previous to that. So do it again. Second function enter, and look. Whoa, it's the same thing. Oh ho ho. So now if I press enter, it will now calculate it for x equals to 3. So, oh ho ho. In this case, it's also 0.
Wait, can you do it again?
Okay, I'll do it again. Sure. Second function enter. Second function enter gives you the previous thing.
Oh, oops.
So press enter first. Press, yeah. Okay. Okay, let's keep going. For part D, what number do I plug in for x? -2. Good. And then once again, I'll say just go ahead and do -2, and I'll store that as x. Okay, and then I'll do the recall, not just once, but twice. So the previous, or the second previous entry, and you get -60. So obviously this one, the result is -60, therefore it's not a factor. Good. Okay. Now how about 2x minus 3? What do I plug in for x? Yeah, it's like you saying 2x minus 3 equals to 0. I'm solving for x, so you get x equals to positive 3 over 2. Now don't freak out. The calculator can do the fraction stuff too. So just type in 3 divided by 2. That will be the fraction. Store it as x. Press enter. Recall once, recall twice, press enter, and you've got the decimal 0.375. Now, by the way, your graphing calculator will also change this to a fraction for you, if you're curious. To change it to the fraction, there's this math button, which is underneath the green alpha button. So if you press math, and you choose number 1, option number 1, it says arrow with a frac, meaning I want you to take my answer that's a decimal and change it to a fraction. Press enter, and voila, 3/8. So in this case, the answer is 3/8. Therefore, is this a factor or not? I say no, because it's not equal to 0. Okay? Now, I want to just do one more quick thing, and then I'll give you a break. I want you to look now. Therefore, if you think about factors, okay, factors are those binomials. which are my three factors of this big long polynomial? Well, it's x minus 1, x minus 2, x minus 3. What I want you to understand then is that this big cubic function now is actually equal to x minus 1 times x minus 2 times x minus 3. And I've actually factored it. But I didn't really show you how. I just said, here are the factors. So the next part I'm going to show you is, I'm really going to show you how you can go from this long cubic into these binomial forms. All right? Now, before I give you a break, one last thing. What do you notice about these factors?
3 times 2 times 1.
Yeah, 3 times 2 times 1 is 6. Or negative 1 times negative 2 times negative 3 is negative 6. So I'll get back to you in a second, but this idea of these factors being multiplied and equal to that last constant is something that we will need to use to help us do the next part. Okay? And really, ladies and gentlemen, all this stuff I've done so far is just to get you ready for the next part. And it's this next part that I really want you to know for your AP Calculus course and for your test on Friday. Okay? You might learn this next year, I don't know. I know they took it out of the curriculum in grade 11, but I think you need it for AP Calculus. That's why I'm showing this to you now. But it's very similar to what we were doing before. Anyways. Okay. Do you want a break? Okay, take a 2-minute break. This is an extension of the quadratic unit. We know how to factor quadratics, okay? So what I'd like you to do is I'd like you to now factor cubics, all right? So these are all cubic equations. You see x cubed? And I'm going to show you now how you can factor them. So, okay, from what we just did earlier, you see how the property I have here in bold? Can you see how the negative 6 from above was equal to negative 1 times negative 2 times negative 3? Well, here's one of the first properties that you need to know so you can actually do this factoring. It says the possible factors of a polynomial with a leading coefficient of 1, meaning it's 1x cubed in front. Okay, that just means 1x cubed. And they are found by testing the integers which divide into that constant term. So what I'm saying to you is you have to kind of guess and test to get that first factor. And to guess and test, which numbers do you try? Well, they're always the integers that divide into that constant term. So let's look at example number 6. What is the constant term for example number 6?
How many do you need?
The negative 8. What times what gives you negative 8?
2 and 4.
2 and 4 I heard. Anything else?
1 and 8.
1 and 8. Anything else?
Wait, but like over there you had like 3. So could we have 3?
You could have 3, but I'm telling you right now, Rebecca, I'm saying tell me all the possible integers.
Oh, okay.
So I'm listing out all the possible ones. 1, 2, 4, 8. You're missing 4 more.
Negatives.
The negatives, thank you. Plus minus 1, plus minus 2, plus minus 4, plus minus 8. Now, I'm saying these are possible factors. Okay? You have to figure out which one actually works. How do I find out if something's a factor? What did we just do above? You took the numbers and you plugged them in. Okay, dear friends, you got 8 choices. Let's see who's lucky today. What number would you like me to try? 1? Okay, let's try x equals to 1, and let's see if the remainder equals to 0. So how do we figure this out? You'll plug in 1 into the expression. I hope you did not give me extra work to do. Sorry. Okay, calculate this, please. 1 cubed plus 5 times 1 squared plus 2 minus 8. Is this 0? No, seriously, is this 0? Oh, it is. Yay! So because this is 0, therefore we know, hey, 1 works. So what's the actual factor? It's x minus 1. Remember how we had to switch the signs? Okay, when you plug in 1, that means the factor is x minus 1. So therefore, x minus 1 is a factor. Now, you got lucky this time. What happens if this first one didn't work out? What would you do next? Try the next one, and try the next one, and try the next one. One of them will always work. Okay? Step 3, it's time to go ahead and do some long division now. So you found your divisor, and that's why I showed you all that long division stuff ahead of time. So now go ahead, please, and do the long division, which you are now experts at, so I'll let you try that on your own. Okay. Okay, double check your answer with mine, dear friends.
Yay, 0.
Okay. Now, ladies and gentlemen, may I remind you that when you're doing this long division for this type of question, okay, there's a simple way you can kind of double check to make sure you are right. What should your remainder be?
0.
Yeah, because you told me that earlier. So if this is not 0, you screwed up. That's not good. Okay, so always double check. In this case, your remainder should always be 0. Okay, so therefore now, what did you actually do? You actually factored the cubic into these two polynomials. X minus 1 times x squared plus 6x plus 8. Now, you know how I had 3 brackets for the previous one? Why do I only have 2 here? Because you can still factor. Thank you. Find 2 numbers that multiply to 8. Those same 2 numbers add to 6. Help, help, help.
2 and 4. Plus or minus.
2 and 4. So what do we have here then? We get x minus 1. That becomes x plus 2. And this becomes x plus 4. And there you have it, dear friends. You've actually now factored your first cubic. It's now x minus 1 times x plus 2 and x plus 4. Ta-da! But wait, there's more. Remember, as an extension, you know how we did factoring, and then I said in grade 11 you can solve for x? Well, now I can ask you this question. What if I asked you to solve this cubic? Well, let's not do this process again, but you would factor, right? So I'll say C above, because I don't want to do it again. And you factored it into this format, x minus 1, x plus 2, x plus 4, right? And now how would you solve for x?
Is it the root thing?
It's the root thing, yeah. So just make each of the binomials equal to 0. You get x equals to 1. You make the second binomial equal to 0. Negative 2. X plus 4 equals 0. X equals negative 4. Ta-da. Now, don't turn the page yet, because I'd like to actually show you visually what a cubic function looks like. Can you actually bring out your graphing calculators now? And I'm going to ask you to actually graph out this cubic function. And I want you to see where the zeros are. And let's hope that the zeros are at 1, negative 2, and negative 4. So let's graph this out. Y equals 2. Type in the function x cubed plus, I guess, 5x squared plus 2x minus 8. Graph it out, and here's what your cubic looks like. Okay. Whoa, up and down. Okay. Notice there are 3 spots where it crosses the x-axis. And if you want to find the zeros, you can, but I'll tell you, this one looks like it's 1. This one here looks like it's negative 2. And that looks to me like it's negative 4. Agreed? Uh-huh. My window here is negative 10, the standard one. Yeah, so zoom standard, zoom 6. There's my graph. Here it comes. The cubic function. Okay. The only thing I want to show you now is what happens if the x cubed term is not equal to 1 in front. Let's say if I change the number, and if you turn the page, here's my last example for today. What happens when the leading coefficient's not 1? Okay. All right. If it's not 1, it's very similar except for one tiny difference. Okay? Step 1's different. Okay. Don't worry, Derek, I'm almost done. Okay, ladies and gentlemen, last one here. Listen up. Okay, step 1 is a little bit different, but the first part's still the same. Look for the possible integers which divide into the constant term. My constant term here is 2, so what times what gives you 2? 1 and 2. Don't forget the plus minus. Okay? Okay. Next part. Here's the difference. Star this, okay? When the number in front is not equal to 1, this is your extra steps right here. I want you to also look for the possible integers that divide into the leading coefficient. Now the leading coefficient is 3. So what times what gives you 3?
1 and 3.
1 and 3. Or negative 1 and 3. Or negative 3. Now, here's the part that is different. The numbers you have to try and test out, okay? Before it was just the values of A. But now, because you have a leading coefficient in front, it's a little bit more complicated. You now have to use all the numbers of this form, of all the values of A divided by all the values of B. You're like, what? Here's what I mean. Just watch me for a sec. I'll give you time to copy this down. You're going to take each value of A, which would be plus minus 1 and plus minus 2. And you're going to divide that by each value of B. Well, if I divide by plus minus 1, well, that's just equal to what? Plus minus 1, right? What about plus minus 2 divided by plus minus 1? That's just plus minus 2. So you're thinking, hey, Mr. Lee, that's the same as before. Nothing's different. You're right. That part's the same. Here's the ones that are different. Remember I said you have to divide by every single term in B. So not only by the 1, now I also have to divide by the plus minus 3. So now not only do you test out plus minus 1 and plus minus 2, you also could test out plus minus 1/3 and also plus minus 2/3. So these are the 8 things that you now can use to test. Write this down now. Okay. So this is the tricky part when the coefficient in front is not 1. Okay?
When you put like 16 things.
It could be 16, 18, you could have more things, you're right. But, when you do step 2, my advice is always to use the whole numbers first, okay? If you try all the whole numbers and they don't work out, then go to the fractions. If you're going to avoid the fractions, always try to avoid the fractions. So for step 2 now, it's the same. So which one of these numbers would you like me to choose? It's guess and test. 2. All right. Does 2 work, or is that just something that you want me to do to try? You don't know. Okay, we'll find out. 3 times 2 cubed minus 4 times 2 squared minus 5 times 2 plus 2. Please, 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 let's hope this works. 3 times 8, that's 24. 4 times 4 is 16. 10. 2. 8 minus 10, negative 2. Oh, ho, ho. Yay, this works.
Good job, Mavis.
Good job. Whoever told me to. Mavis, thank you. So therefore, since 2 works, what's the actual factor that works? It's the opposite, x minus 2. Okay, so therefore x minus 2 is a factor. All right. Okay, I leave the fun stuff to you now. It's time to do some long division. Okay, and I'm going to ask you to factor this, please. So you try this. And then also do the extension and solve. And then after that, we're done. You didn't factor this yet?
Monday, Wednesday, Friday.
Okay, there's my answer, by the way. Okay. By the way, once again, you need to actually continue to factor this, because I believe this quadratic here can be factored further. Did anyone do that for me yet?
Wait, almost there.
Wait, what do you mean? I gave you lots of time.
No, you didn't.
Remember, 2 numbers that multiply? Sure. Choose method. 2 numbers that multiply to negative 3. Same two numbers add to what?
2.
2. What are they?
Negative 1 and 3.
Negative 1 and 3?
Yeah, yeah.
Yeah, okay. So I guess you have what? X minus 1, x plus 3. Don't forget to do what after that? Divide by 3. Okay. Remember to simplify. Remember to bottoms up.
Alright.
All right. Are those the 3 factors that you have in your notes? Sure. And if it is, then sure, you're right. And if it's not, sure, you're wrong. Okay? And of course, if I ask you to do the last part, the extension then, well, not too hard since you've already done the factoring. I'm just going to ask you to tell me what the answers for x are. And to do that, let me just quickly copy out the factored form of the cubic first. And I want you to solve, so x equals to 2, x equals to 1/3, x equals to negative 1. Okay? Now, ladies and gentlemen, just for some practice, I gave you some questions to try down here. You should do as many as you need. Let me just tell you to solve by factoring, and just to let you know, I'm asking you to solve over the real numbers. Okay, so real answers only, no imaginary stuff, please. Okay. And ladies and gentlemen, I've given you the answers underneath as well, so if you want to double check, they're here. Now, in terms of, do you need to hand this in for homework?
If we don't,